Okay, so let's go ahead and look up the warm-up. Sometimes we skip them, but I think it would be good to go ahead and see which ones we think are linear equations. Okay, so I'm going to have you just do it in parts. So let's see here. On Edpuzzle, can you tell me out of A, B, and C, which ones are linear equations, and be sure to mark all that apply. All right, so A is a linear equation, B is a linear equation, C is not, because when you try to get y by itself, you end up with a square root with an x inside, and you cannot have x inside a square root for it to be linear. Okay, so let's look at another section. Let's look at D, E, and F. So out of D, E, and F, which ones of these are linear equations? Make sure to mark all that apply. All right, D is a linear equation. E is not because you have the x inside the square root. Now F is tricky. F is a linear equation because remember I told you couldn't have the x inside absolute values, but the x isn't inside the absolute value. The absolute value of -2 is 2, and you have the x outside, so it can be rewritten in y equals mx plus b form. Okay, out of G, H, and I, which ones of these are linear equations? And select all that apply. All right, so G is a linear equation because you could multiply both sides by 3, and what that would look like is you would times by 3 and then times this side by 3, and so you get 3x plus 15, and that is in y equals mx plus b form. H is not a linear function because you cannot have the x in the exponent, and I is not because you cannot have x squared or the y squared either. This is actually the graph of a circle. All right, so a little bit of review for us. So let's go ahead and talk about discrete and continuous domains. Okay, I'm going to go ahead and flip to our foldable. So this is the last page in our foldable, and then we should be ready to go ahead and glue it in our interactive student notebook. So discrete or continuous. The discrete domain, all right, discrete, is a set of all inputs, x values, that consist only of certain numbers. So I'm going to give you an example in just a second of that. Let's talk about continuous real quick. Continuous is a set of all input values that consist of all numbers in an interval. So discrete is like buying cans of corn. If you go to the store and you want to buy a can of corn or 5 cans of corn, you have to buy them in whole values. You can't buy partial amounts. So you can't say, hey, I'm not that hungry. There's only one of me. I only need half a can of corn. You can't crack open that can at Dillon's, pour half on the floor, and go up to the register and expect to pay half price. So you have to only buy certain amounts. You can buy 1 can, 2 cans, 3 cans, and so on. Okay, continuous is more like, how about buying, let's say buying apples. So on apples, usually when you go buy apples, they're priced by the pound. So it doesn't matter how many you buy, it matters how much they weigh. So they may say like, hey, they're $2 per pound. So if that happens, then you can buy 2.1 pounds or 2.2 pounds or 3.57 pounds because the weight is not attached to just specific numbers. So if you're buying apples, and we should probably say by the pound, because I know some places you pay, like at Quick Trip, you pay by the apple. So if you're buying them by the pound, then you could have any partial amounts above 0. I mean, you can't have 0 pounds. That would be 0 apples. So anything above 0, you could have partial amounts. You could have really large amounts if you're buying a lot of apples. So let's look at the example they have. The linear function y equals 1.25x represents the cost in dollars. Okay, we always write this down. Y is the cost in dollars, okay? And X is how many bottles of orange juice you buy. So number of bottles of OJ. All right. Each customer can buy a maximum of 5 bottles. Find the domain of the function. Is it discrete or continuous? Well, first of all, the domain of the function, they said a maximum of 5 bottles. So they can buy 0 bottles, they can buy 1 bottle, 2, 3, 4, or 5. It would just be this set of points. They can't buy 2.6 bottles if that's what they want. If they only need a fourth of a bottle for a recipe, they can't buy a fourth of a bottle. They can buy nothing, or they can buy them in whole bottles. So that means this is discrete, because if we graphed it, it would graph and we would not be able to connect the dots. It would be like, hey, you can only buy these certain things. All right, so let's look at a graph. So it's really, really easy to remember. A discrete domain is going to be a, when you have it on the graph, it's going to be a set of points. Because the points are indicating, like right here, whatever this story would be, that you can only go and you can only have those amounts. You can't have the amounts in between the dots. So like halfway in between, like right here, you can't have that. So this would be a discrete graph. Continuous literally means, all right, when it's continuous, that you can draw the graph without ever lifting up your pencil. It's continuous. It doesn't have a breaking point. It doesn't being dots over and over. So this is continuous because we could absolutely draw that line without lifting up our pencil. Okay, let's go and let's do some examples on our notes page. So let's go ahead and go down to example 4. Okay, so on example 4, is the domain discrete or continuous? So the input is the number of stories, X. All right, so how many stories a building is tall. The output is how tall the building is, like how many feet high it is. So in this case, this would be continuous. And our reason is, if you think about the height of the building, you can have homes that are 1.5 stories. That's absolutely possible. You can have buildings that the first story has more feet than the other stories because maybe they have like a ground floor with a big vaulted ceiling, and so it's like has a really grand entrance. So basically, you could have any output. Your feet of the building could be anything, any number that's greater than 0. So basically, I mean, you can't have a building that's 0 feet high. You don't have a building in that case. So you can have any number greater than 0. And it can go, I mean, theoretically, there is a cap on it, but it would be continuously growing. You could have buildings that are 36 feet tall. You can have buildings that are 41 feet tall. There's no specific number they have to be. Okay, let's look at relay teams and athletes on B. So relay teams, can you have a partial team? Can you go to a track meet and say, hey, we don't have all of our people here, so we're just going to compete, in the 400 relay with just 2 athletes. You can't do that. You have to have 4 people on each relay team. So that is discrete because you can't say, hey, I'm going to race with just half a team or just 1 person. So your numbers on your output are going to be in multiples of 4. You can have no teams. You can have 4 people, which is 1 team, 8 people, 12 people, 16, and so on. So it's discrete because your output has to be very specific numbers, not the numbers in between. Okay, let's look at example 5. So it says, write a real-life problem to fit the data shown in each graph. Is the domain of the function discrete or continuous? Well, first of all, the one with the points is discrete, and the one that we can draw without lifting our pencil is continuous. So now let's think of a problem that would fit the data shown. This could vary, so let's just kind of talk about it together. So this one starts at 6, and then it goes down by 1 as it goes over 1. So something that starts with 6 and goes down by 1. I could say I start with 6 apples and I eat 1 a day. And that would be discrete. I can't, if I eat half an apple, it's not going to last till the next day. I'm just going to throw it out. So I start with 6 apples and I eat 1 each day. And so here's the 6. After 1 day, now I'm down to 5. After 2 days, I'm down to 4. After 3 days, I'm down to 3, and so on. Okay, let's look at something continuous that you could have partial amounts for. So what if I, what if I start with, how about 6 gallons of gas? Okay, and let's say I mow, and I use 1 gallon per hour of mowing. So I'm mowing yards for a business. Well, okay, when I haven't mowed any, I start with 6 gallons. but you can mow for partial amounts of time. So I could mow for like 2.6 amounts of time, and that means I'd have just around 3.5 gallons left. Or I could mow for 4.1 hours, and that means I'd have just under 2 gallons left. And so all of these points on here are possible because you can mow for, individual amounts of time, based on minutes, seconds, hours. And you can also have different amounts of gallons of gas. You don't just have to have exactly 5 gallons. You can have 5.2 gallons. So that is continuous.